Hi, welcome to Pear. I'm Stephanie Hobbs. Today we will be doing your technical interview. Is there any questions you have before we get started?
Yeah, what are kind of the environments you'll want me to be working in?
Yeah, so today we will be working in LeetCode. You will be solving a search insert position problem. You can do that in any language you're comfortable with, and then we can test it. Feel free to ask me any clarifying questions if you have them.
Okay, thank you.
Yeah, of course.
Do you think you could help explain the problem for me?
Yeah, so today what we're going to be looking at is the search insert position. What we're going to be doing with that is you're going to see an array of numbers. You're going to be asked to find a target. If that target is in that array, you're going to output the index. But if that number is not within that array, you're going to print out the index of where that number should be within that array. And so, for example, if we have 2, but in our array 2 is not in that array, it would print where it would meant to be. So that would print index of 1.
Okay.
Yeah.
Cool. All right, well, let me get my environment set up here and I'll start working on that.
Okay.
Okay, so I see that we have our example inputs like you were talking about with nums equal to 1, 3, 5, and 6. We have target equal to 5, so the output where index is 2 would equal 2. So I think what we can do for this is a binary search. One of the ways we could do this is we could have n equal to the length of nums, and what that would allow us to do is now that's equal to length of nums, and we could set L for left equal to 0. And I think if we did right equal to n minus 1, so now because the index starts at 0, we would do minus 1 of the length of the list to ensure that we return the correct index. And then we could have b equal to n. So what we could do with this is we could create a while loop. So while the left is less than or equal to the right, we could then set, we could probably just make a throwaway variable in here just called mid, and with that we could set that equal, so it would be like the middle of the list, which to find that we would need to set left plus right, and then we would modular that by 2, so that would give us the middle of the list. Now with this while loop, if we took if nums and we went to the mid, which would be that index, and we set that equal to greater than or equal to target, which would be another throwaway variable within this while loop, but it wouldn't matter too much because we can just set that and put b equal to mid. So while this nums is at the index of mid and it's greater than or equal to target, we can set b equal to mid and h equal to, you could probably do mid minus 1, which then, it's going towards that direction. And then else, if you didn't have nums mid greater than or equal to the target, then you could probably say, left is equal to mid minus 1 as well. So that way, either way, you're going to be either going to the left or to the right, and it'll keep doing that as long as left is less than or equal to r. And then at the end of this, we would probably just return b, since we can't return mid. I set it equal to L plus R modular 2, but it was set equal inside the while loop, so we can't really return it. So we'll just try return B, and let me see if that does it correctly.
Okay.
Oh, I'm getting a runtime error on n equal to length of nums. Let me check what could be wrong. Length of nums, which I'm not sure why. Do you have any ideas as to why it would be stopping right there?
Yeah, from what I'm seeing, we just need to make sure we're keeping our indentations consistent as in Python. So if we can just make sure that's correct, I think that we shouldn't run into that problem anymore.
Okay, I see.
Yeah.
So I think if I just tab this, then that should run. Oh, looks like I when I tabbed, return went. See, sometimes tab is good, and other times it can mess things up. Let's try that again. Oh, I see. I made a mistake. Here I put h equals mid minus 1 when we were supposed to have r. And it also seems that I had accidentally put l equals mid minus 1 instead of l equals mid plus 1. So let's see if that gives us the correct result.
Okay. I'm glad you caught that problem.
Oh, and it looks like it was accepted.
Oh,
Cool.
Great. And can you explain to me why this is O log n?
Well, that would be because we use the binary search, and in using that, you reduce the amount of stuff that the program has to go through. Rather than brute forcing it, it can go through and it splits it at the midpoint, and then it just keeps splitting it, whether it's on the left side or the right side. And so it greatly reduces the amount of stuff that the program has to do, as opposed to just going from 1 to wherever the end of the program is, which would be really inefficient.
Right.
But
All right. Well, great job. It was so great having you here today, and we will be in touch. Thank you again.
thank you.